I'm just going to start doing some of these exercises where we use the substitution rule. If you have any questions, speak up, but you are recorded. Anyway, okay. So we'll see how this goes. So I'm taking these problems directly out of the book, starting off with number 1. For the first few problems, 1 through 6, they tell us what U is for our substitution. Now, the substitution method is dealing with compositions of functions. Well, sometimes you don't even really see there's a composition, but somehow it turns up. So the inside function is what we're going to call U, like always calling it U, and it's not just me, that's pretty much how it goes. And so I have U equals 2x, and I take the derivative of U and I get 1, and I write 1 du, or just du. On the right-hand side, I take the derivative of 2x and I get 2, but then I put dx. So over here, we're doing derivative. Now, my way of doing this, and I'm following the book, is I really just want to find out what dx is. So that says 2 dx. I'm going to divide both sides by 2, and I'll write 1/2 du equals dx. So as I show here, 2x is equal to u, but now I have that dx is equal to 1/2 du. So let's bring the 1/2 all the way outside of the integral, and then I'll have cosine u du. And the idea that's so nice about this substitution method is that I can now only focus on the outside function. So there's a composition of y equals cosine u and u equals 2x. But I'm only going to integrate at this point the cosine u. And the antiderivative of cosine u is sine u. And I'm going to put plus c because this is a indefinite integral, which is essentially actually not, it's the same thing as being antiderivative. Now let's double check. The derivative of sine u is cosine u, so that makes sense. And then what I do is I replace u by 2x. And that's our answer. Do you have any questions on that? Let's move on to another problem. All right, here, once again, u is given, it's provided. U is x to the 3rd power. Change color for whatever reason, sort of annoying maybe that I do that, but okay. U is x to the 3rd power plus 1, and we're going to let u equal that. So let's go over to the right. U is x to the 3rd plus 1. I take the derivative of u and I get du. For x to the 3rd power plus 1, I get 3x squared dx. All right, now I am only going to divide both sides by the constant 3. I will go ahead and even say that's wrong. Even if you might have seen it somewhere else, I'm going to say it's wrong if you divide it by 3x squared. And the reason is I do not want to mix the x's and the u's. I'm sure some brilliant people do that. Actually, I'm not so sure. I'm going to follow the way Stewart does this, and it looks nicer. I think it's better because it's correct all the way through. But anyway, actually, what did I do here? I put the arrow not really where I wanted it. I want the arrow from here to here, meaning, again, derivative. Just want to make it clear that we do the derivative right there. Okay. So now this next step is sort of optional, but I'm going to sort of reorganize things to hopefully make it more clear what's going on. I'm going to put the x squared right next to the dx. And so x squared dx is equal to 1/3 du. And then this x to the 3rd plus 1 is equal to u. So this all becomes, let's bring the 1/3 all the way to the front. 1/3 integral u to the 1/2 du. Okay, then I use the power rule. How does the power rule work? I have u to the 1/2. I take 1/2 and I add 1. Usually I don't do that showing that work. I do 1/2 plus 1 in my head. I think, you know, people get pretty good at that. And so this becomes 1/3 u to the, I need to get a little more space. So, okay. So I have 1/3. Always wanted to look neat. 1/3 u to the 3/2 divided by 3/2 plus c. Some people from the very start multiply by the reciprocal. Right, that's what we're going to do, is multiply by the reciprocal of 3/2 because we're dividing by 3/2. So then we're going to get 2/3 here. And then u is x to the 3rd plus 1. And I raise that to the 3/2 power plus c. Now, I'm going to follow what I believe is the convention of the author, which is not to express this as a radical when I have to 3/2. I'm just going to leave it like that. That's, I think, the answer I would see in the back of the book. Okay, and so we have that one right there. All right, so those are both using U substitution. This one's, I don't know if it's that much easier, but probably they're giving us U to begin with. So that's like a little bonus, a little head start. So they give us U to begin with, and then we work with that. Okay, I'm going to stop recording.